Hello everyone. I'm here with Beverley today to explain the application of direct proportions in daily life. Let's get started.
So, what is a direct proportion? A direct proportion is where two values or two quantities increase or decrease at a constant ratio. So, basically, think of normal ratios like 1 to 2. If you increase them, they stay at the ratio of 1 to 2. They stay like that. That's direct proportion. So, we have a sample question. How far would you drive in 3 hours if you're driving in a car that's moving at 100 kilometers per hour consistently?
All right. So then let's solve it together. So now we know that speed equals to 100 kilometers per hour. Then we know that time equals to 3 hours. By using the DST triangle or distance time speed times time, we get that distance equals to speed times time. So we can substitute speed with 100 kilometers per hour. Time equals to 3 hours. So then we get 300 kilometers.
So this is the graph we are using to solve the equation where the time increases with the distance traveled or the kilometers. So when you it's 1 hour you're moving 100 kilometers as you see over there, and 2 hours you're moving 200 kilometers, 3 hours you're moving 300 kilometers, and etc. like that.
So lastly, we have the table. So in time per hour, yes, as you see, we're just using this for to organize uh on how long. You see, in an hour we go at 100 km, then 2 hours and 200, then so on and so forth.
Hi everyone, I'll be explaining about inverse proportions. Inverse proportion means when one thing goes up, the other goes down, but the product stays the same. We can write it as y equals to k divided by x, or x times y equals to k. So let's look at one example. If a tap fills water at 50 milliliters per second, and we want to fill a 1 liter bottle which is 1000 milliliters, then the time it needs is 1000 divided by 50, which is 20 seconds. So it takes 20 seconds to fill the bottle. If we plot this on a graph, on the x-axis we have the flow rate, and on the y-axis we have the time. As the flow rate increases, the time decreases. Instead of a straight line, the graph forms a smooth curve that goes down, showing that when one number increases, the other decreases. That's what inverse means. Now let's look at this table. It shows the flow rate and the time needed to fill the same bottle. At 25 ml per second, it takes 40 seconds. At 50 ml per second, it takes 20 seconds. At 100 ml per second, it takes 10 seconds. And at 200 ml per second, it only takes 5 seconds. So every time the flow rate doubles, the time halves, proving they're inversely proportional. So in simple words, the fast tap is equal to less time, the slow tap is equal to more time, but both always balance each other.